I'm Stephan, I'm a sales engineer at Mugato, and today I would like to show you how to solve technical debt with Mugato. Imagine one company, multiple sites worldwide, and a decision from the board. Everything moves to a central data center. Sounds simple, right? Better control, lower costs, easier management. But here's what nobody really expected. For the last 20 years, each site worked independently, running its own applications and its own infrastructure. Each site solved problems pragmatically and quickly, yet locally. So what is technical debt? According to Howard Cunningham, technical debt represents the hidden costs that build up when you choose quick and local solutions instead of well-designed company-wide systems. Each site developed its own isolated IT solutions over time. Solutions never designed to work together. The result? A complex patchwork nobody fully understands anymore. And now we are moving all of this into a central data center. That's when we discover the real problem. The board approved a 150 million transformation program to consolidate 15 local data centers into one big facility. The timeline for that, 24 months. The expected savings, 30 million per year. The CMDB shows 450 applications in total. Network diagrams show clean connections. And the assumption is we have 50 to 60 dependencies in total. What does the reality look like? After 3 months, the discovery shows that Berlin alone has 180 applications, not the 45 as documented. After 6 months, the first migration failed. The HR tool connects to 8 unknown systems. Custom timesheet system on an unknown server, access control system, the canteen payment, reporting tool connecting to another 3 apps, nothing documented. After 9 months, production planning at Vienna exchanges data with 23 systems via custom scripts, file transfers, email automation. One engineer built this over 15 years, retired 2 years ago. No documentation. After 12 months, status is red. Only 15 applications have been migrated, but the target was 180. The budget is at 90 million of planned 115. Timeline is already extended by 18 months. To conclude, each site optimized locally. For example, by solutions like I just write a script. We have shadow IT. We have departments which build their own tools. We have undocumented dependencies everywhere. Everyone knows that system X needs system Y, but it's not written, it's not documented. We have knowledge that is gone. The result? A network of connections nobody understands. Moving one application means understanding connections to dozens of others. Connections that were not designed, they just grew over time. This is technical debt. When you migrate to a central data center, you pay back that debt with interest. So what does technical debt cost us? Let me show you 3 possible consequences. The first one, remember our 150 million euro 24-month program? Here's a reality. 24 months became 42 months. 150 million became 245 million. Only 15 of 450 applications have been migrated in the first 12 months. Every undocumented dependency requires additional analysis, re-architecture, extended testing, sometimes even complete rewrites. Projects constantly replanning based on newly discovered dependencies. Stakeholder trust gets lower with every day. And it's about business risk. 3 critical migrations failed in production. One caused 8 hours of production downtime, 2 million euros lost in production. Why? A dependency on a legacy database that was supposed to be read-only was actually being written by 5 other systems. And also security might feel uncomfortable with unknown system, as it means unknown security vulnerabilities. An internal audit might ask, are you migrating systems that are not fully documented? And while IT is busy fighting fires in this migration, the question is, what is actually not happening? Strategic initiatives delayed. Digital transformation projects are on hold. New product launches requiring IT support delayed by months. Innovation, zero, because everyone is in crisis mode. Competitors are launching new digital services, but we are stuck in migrating 15 years old applications. And our best engineers leave because they didn't join a company to work on 20 years old legacy code. Let me be very clear about something. Technical debt is not an IT problem. It is a business problem that directly threatens innovation, profitability, and competitiveness. Okay, so how do we solve this? What solutions are available? So first, you need to create transparency before you start. Who would benefit from that? Well, first of all, it's architecture and the PMO. Before you migrate anything, map the actual dependencies, not what's in outdated documentation, automatically discovery and collection. Which applications actually communicate with each other? What data flows where? Which connections are critical? Where are your hidden dependencies? The result will be IT architecture finally sees the real landscape, not the documented one. The PMO can finally create realistic migration waves based on actual dependencies. No more surprise discoveries after running this project for 6 months. And this is exactly what Mugato gives you. What we see here is an overview of all the applications that we have, how they are connected to each other, and the dependencies they all have to each other. Let's take one quick example. Let's focus on that application that is called SQL Server Dev 1. Let's put it into the focus and let's try to find something out. This application service is consumed by all these services around. And one of the first things that we show here is that production ERP system, which consumes obviously a service from a development SQL server. We can even go further down. We can drill this application down to the actual servers. And then the most important question is, what server within your production ERP system is actually talking to that device? And we can again drill it down and we can find out the direct communication. We have a production server here and we have a server here that communicates to each other. And please don't get confused with the prefix prod for that server. That is a demo system where we had to sanitize all the server names. But trust me, this is a development system. So the dependency map that I showed you requires that you know your devices, right? Which is not always the case. So you know that you have unknown devices on the network. And what you would typically do, you would run network discovery in order to identify them. But as you also know, not every device can be discovered on the network. Think of the case where an entire business unit is hiding their devices behind a firewall. So the only thing that you would detect when you run a network scan would be that firewall device. But these devices, though hidden, might still communicate with your production systems. So Mugato does also show you these devices that you are unable to detect through network discovery. Because the thing is that all these devices still communicate with your production servers. So we look at these production servers that we already know, and if you take this example of this SQL server, we see connections from devices that are unknown to us. And your next step would now be to identify these devices. Where are they coming from? Whom they are belong to? Do they play a role within that application service? And at the end, you will make sure that there are no white spots anymore on your network, that you know each and every device, so you eventually have 100% perfect overview of your application services. Let's look at another example. Let's assume you want to understand how communication looks like within a single application. So what we have here is we have these servers forming that application and we just go into the process view and we get an overview and a summary of the different components of the different systems within that application and how are they communicating to each other. And it gives us again some interesting information because we could actually analyze and inspect the connections. And what we see here on that picture is actually the protocols that are being used. And from the protocols, we get an idea of what services are being consumed. And though this is an SQL server, as you can clearly see on port 1433, we also see for some time connection through 445, which indicate that this server is obviously misused for Windows file services. It started here and it ended here when the security guys detected it. So with that information, you are not only able to tell what systems, what components form a certain application service, but you can also break it down to the communication between these systems, and you can also conclude on the data flow. Now we know how many application services we have, we know what is connected to each other, we know what the dependencies are, there are no white spots anymore. The next question is, in what sequence we're going to transform these application services, because you remember we still have that program where we need to consolidate 15 local data centers into one large one. And the answer to that is automated migration sequencing. So that most of all benefits the PMO and the project managers. Instead of guessing which applications have to be migrated first, the migration sequence is automatically suggested by Mugato based on the actual dependencies. For example, if you have an application service, case management, which depends on that application service, which depends on Office 365, which depends on this service, and so on and so forth, it is quite clear that it would be a mistake to choose this application service for the first transformation waves. So what Mugato does is, based on the dependencies between all these application services, it tells you what the transformation sequence should look like. So you start with these application services that have no to little dependencies. These you take first. And then you focus on these applications with more dependencies because they have to be migrated at the end of your schedule. Let me close with this. The example that I brought at the beginning, that 150 million euro 24-month data center migration project with proper dependency visibility and automated sequencing from day one, the realistic timeline would have been 36 months, not 42. A realistic budget would be 180 million, not 245. But most importantly, predictable with no catastrophic surprises. Technical debt is solvable with transparency based on reality and facts, not outdated documents and assumptions. Thank you.